topic in grade 8 maths, and it is all around number. Numbers are really the essence of mathematics, izibalo, and we are going to try and really develop some skills and some competence in number in this topic. Okay, all we're requiring from you is a really, really positive attitude. The first activity that we're going to do is we're going to write our name on this line over here. So my name's Paul, and then we're going to do 5 different tasks, and each of them is going to come up with an answer, and we're going to find it would be a number, and we're then going to find that number in this table, and we're going to complete the word over here. Right, I'm just going to do the first one for you. So think of a number. I'm going to maybe start with 8, double it, I get to 16. Add 6, I get to 22. Halve it, I get to 11. Subtract the number I started with, right, I get to 3. And add 16, and I get to 19. Right, so 19 is in fact the first one. And if I go look up under 19 is S. Right, so we want you to complete the rest of those tasks. And if you do it correctly, you will get a word here which tells you something about yourself, and it's something that I really, really believe, and that you need to believe too. Okay, so that's the first activity. Our multiplication tables are absolutely essential. We need to learn them, all right? We need to make sure that we've got them kind of down pat. As you learn them, for example, if you've learned your, let's say, your 6 times table, all right, it will, let's say you've learned up to 6, then in a way you've learned the first few of your 9 times table, because remember that 6 times 9 is exactly the same as 9 times 6. So if you've learned that 6 times 9 is 54 in your 6 times table, then you know that 9 times 6 is also 54 in your 9 times table. Learn them. Right, we're going to show you a little activity here which allows us to practice our times tables. Right, so I'm just going to show you how this works. We're going to start off just by putting the numbers from 0 through 9 in these circles in any order. All right, so let's go 9, 4, 3, 8, 7, 2, 5, 6, 1, and 0. Right, now what we're going to do is we are going to think of a number that we're going to start with, for example, 3, all right, and we are going to start with an operation, so some numerical operation. So let's start off, and we're going to do add 6. Okay, so the first one we're going to do is we're going to start at 3, and we're going to add 6. So our first answer will be 9. Then we move around the circle in a clockwise direction. The next answer will be 8 plus 6, 14. The next one, 7 plus 6, 13. 2 plus 6, 8. 5 plus 6, 11. 6 plus 6, 12. 1 plus 6, 7. 0 plus 6, 6. 9 plus 6, 15. And 4 plus 6, 10. Okay. Right, and we need to develop our skills. So your teacher is going to help you with this, and we're going to do some. I'm going to do another example. Let's just do, for example, let's start at 2 this time, and this time we're going to multiply by 6, right? So we're going to start at 2, we're going to multiply by 6, we get 12. We go to 5, we get 30. We go to 6, we get 36. We go to 1, we get 6. We go to 0, we get 0. We go to 9, we get 54. We go to 4, we get 24. We go to 3, we get 18. We go to 8, we get 48. We go to 7, and we get 42. Right, and we really need to develop fluency in this. We need to do lots and lots of practice, all right, and your teacher is going to test you on different tables each day with this tool. Okay, right, by now we're sure that you've noticed that, for example, 8 times 7 is the same as 7 times 8, all right, and also that 5 plus 3 is the same as 3 plus 5. It makes sense, right? Now, this rule is called the commutative rule, all right? It means that we can swap the order around and we get the same answer. Multiplication and addition are commutative. However, subtraction and division are not. So what this asks us to do is to take an example for each and to show that. So for example, if we look at subtraction, let's take two numbers and subtract them, right? For example, if we take 10 minus 7, we get 3. But if we take 3 minus 10, sorry, just swapping it around. 10 minus 7, we're swapping it around. 7 minus 10, we don't get 3, right? We actually get minus 3. We get a different thing, right? Don't worry if you're not 100% sure why it's minus 3. We're going to get into integers, and we'll see why that's the case, right? Let's look at division. Division is also not commutative. So let's just take two numbers and divide them. For example, 8 divided by 4, and we get 2. But when we divide 4 by 8, right, think of 4 sweets divided by 8 people, we actually get half a sweet each. All right, not the same. Okay. Another rule is that we can multiply and kind of group numbers in any order. So for example, here we can go, if we're multiplying 8 by 2 by 5, we can either multiply the 8 and the 2 first and then multiply by 5, or we can multiply the 2 and the 5 first and then multiply by the 8. Okay, right. Okay, what we're going to do now, we're going to ask you to do the sum and the product of these digits 2, 3, and 5. We've done the first one for you, and we're going to kind of do all the possible groupings. So notice, firstly, we leave the 2 and we add the 3 and the 5. We get 8. We add the 2 and we get 10. If, however, we add the 2 and the 5 first, we get 7. We add the 3 and we get 10. We want you to show that you're going to get the same answer each time, no matter how you do it. So we're now going to do 1, 2, and 6. All right? Let's have a look. 1, 2, and 6. So if we leave the 1 first and we add the 2 and the 6 and then add the 1, we're going to get 8 plus 1. We're going to get 9. Right. Let's leave the 2 and add the 1 and the 6 and then add the 2. We're going to get 7 plus 2. We're going to get 9. Let's leave the 6 and add the 1 and the 2, and then only add the 6. We're going to get 3 plus 6. We're going to get 9. Okay, we're going to do exactly the same now, but we're going to multiply. So we're going to leave the 1 at first, and we're going to multiply the 2 by the 6, and then only multiply the 1. We get 12 times 1, which is 12. This time we're going to leave the 2. We're going to multiply the 1 and the 6 first, and then multiply in the 2. We get 6 times 2. We get 12. This time we're going to leave the 6. We're going to multiply the 1 by the 2, and then only by the 6. We get 2 times 6 equals 12. Notice different ways of calculating an answer and getting the same answer. Okay. Right, let's do exactly the same. This time we're going to use 2, 3, and 4. We're going to leave the 2. We're going to go 3 plus 4, and then add the 2. We get 7 plus 9. Sorry, we do not get 7 plus 9. I'm getting ahead of myself. We get 7 plus 2. We get 9. Let's leave the 3 and add the 2 and the 4. Then only add the 3. We get 5. We don't get 5. We get 6. Plus 3, we get 9. Let's leave the 4 and add the 2 and the 3. This time we get 5. Then add the 4, and lo and behold, we get 9. We get the exact same answer. We're going to do the same, but we're going to do it with the multiplication. We're going to multiply 3 by 4, and then only multiply the 2. We get 12 times 2. We get 24. This time, we're going to leave the 3. We're going to multiply the 2 by the 4, and then by the 3. notice that we get 8 times 3, and once again we get 24. This time we're going to leave the 4, we're going to multiply the 2 by the 3, and then by the 4, and we get 6 times 4, and we get 24. Okay, let's try with 2, 3, and 6. We're going to leave the 2. We get 9 plus 2, we get 11. We're going to leave the 3 and add the 2 and the 6. We get 8 plus 3, we get 11. We're going to leave the 6. We're going to get 2 plus 3 and then add the 6. We get 5 plus 6, we get 11. All right, let's do the same with the multiplication. We're going to leave the 2. We get 18 times 2, we get 36. This time we're going to leave the 3, so we're going to go 2 times 6, and then multiply by the 3. We're going to get 12 times 3, we get 36. And lastly, we're going to leave the 6, so we're going to go 2 times 3, and then only multiply by the 6. We get 6 times 6, we get 36. All right, it's just playing with numbers and convincing ourselves that we get the same answers. At the same time, reinforcing these rules. All right. Okay, choosing the numbers in the way in which the order rather in which we multiply and add numbers can simplify things for us. Okay, so if we look at this, we're multiplying 25 by 17 by 40. If we choose to multiply the 25 by the 40 first, and then by the 17, this might become a bit simpler. All right, I'm going to think of another way of looking at this. 25 times, I'm going to change the 40 into 4 times 10. Right? And in fact, what I get here, 25 times 4 is 100, times 10, times 17. 100 times 10 is 1,000, times 17. 17 lots of 1,000, 17,000. That's actually much easier than multiplying 25 by 17 and then by 40. The same thing happens with addition. These two are going to add up nicely to give us 100. So let's add them first. 80 plus 20 plus 173. We're going to get 100 plus 173. We're going to get 273. Here's a multiplication one again. Let's multiply the 20 by the 50 first. Right, 20 times 50, well, 2 times 5 is 10, but each of them has an extra 0 on, so in fact 20 times 50 is 1,000. Times by 83, final answer, 83,000. Okay, notice we always are working downwards in maths, and we are underlining our answers. The other thing that I have been slack about is we are writing equals on every line, right? This line is the same as that line, is the same as the same as the same as the same, right? And likewise, it's the same as the same as the same. Okay, this last one involves some addition. Let's rather add the 97 and the 3 first, and then add the 234. Right. And we get 100 plus 234. Final answer, 334. Okay. Right, we're just working with numbers and getting more and more comfortable with them. Right, here's some space for your teacher to make up some extra examples. And that brings us to the end of this lesson.